Hello everyone, my name is Jay Pidley. Today I am excited to present my Google ADK capstone project, Enterprise Financial Crime Investigation Agent. Having worked in financial crime surveillance, I've seen how investigators spend a significant amount of time gathering evidence before they can actually investigate the suspicious activity. Now, this project explores how Google ADK, Gemini, and MCP can be combined to automate evidence preparation while preserving security, explainability, and human oversight. Financial institutions, as we know, generate thousands of AML alerts every day. A typical investigator must retrieve customer information, review the transaction history, assess jurisdiction risk, identify triggered rules, and document findings across multiple systems. Now, this repetitive work reduces the time available for actual investigation. My objective here was to demonstrate how an agent-based workflow can automate all the evidence preparation while keeping investigators in control. Now, this problem is naturally suited to agentic AI because it consists of several coordinated activities rather than a single AI prompt. I've designed three specialized agents here: an alert normalization agent, a financial crime investigation agent, and an explainable recommendation agent. Together, they create a modular, explainable, and secure workflow. Every investigation begins with an incoming AML alert. The alert is normalized, evaluated by deterministic AML rules, and validated by enterprise guardrails, including input validation, prompt injection detection, PII masking, tool authorization, and output validation. The investigation orchestrator retrieves customer profiles, transaction history, and country risk through MCP tools. An evidence package is assembled and passed to Gemini, which generates an explainable recommendation before the case proceeds to human review and audit logging. Google ADK provides the orchestration layer for the solution. Each agent has a dedicated responsibility while collaborating as a sequential workflow. Now, this separation improves maintainability and mirrors enterprise system designs, as we have in large enterprises today. Enterprise data is accessed to fast MCP tools rather than directly by the language model. Dedicated tools provide customer information, transaction history, and country risk, creating a secure and extensible integration pattern. The security here was treated as a first-class design principle. Before even AI reasoning begins, the platform validates inputs, detects prompt injection attempts, marks sensitive information, authorizes tool access, and validates AI outputs. These deterministic controls improve trust and governance. The recommendation is intentionally structured rather than a free-form text. It includes the recommendation action, confidence score, rationale, supporting evidence, and suggested next steps, enabling investigators to understand why the AI reached its conclusion. Here, the entire package was unit test 54 various use cases covering all major workflow components. Auditability here you can see covers an agent action, MCP tool invocation, and decision outputs that is written to an appended on the audit log. Deployability covers fully reproducible architecture with local setup, Python Pydantic stack, and a dedicated CLI demo runner. As we know, the AI is the analyst and human is the decision maker in this particular tool. The human in the loop ecosystem covers the agentic system functions as an elite digital analyst, handling the 80% of mundane aggregation, rule scaling activity, and preliminary reasoning, so that it can present a perfectly structured brief to the human investigator. Takeaway with this is by automating the bottlenecks here, investigators can reclaim their time to what they do best. Yes, that's to exercise the expert human judgment. Now here I'll show you a demonstration of the workflow which I have created, the actual platform in the prototype. This platform retrieves an AML alert. It executes the guardrail, receives evidence to MCP tools, applies deterministic AML rules, builds an evidence package, and invokes Gemini to generate an explainable recommendation. Finally, the recommendation is returned to the audit log and presented for human review. I'm just clicking on the demo file, Python mock contest, and here as you can see, it has generated the output. It has gone through various stages. It has received the alert. The alert has been normalized. Security guardrails executed fast, and all the other various steps just successfully passed with final investigation recommendation, with the last human review pending and awaiting the approval. This is the end-to-end investigation architecture showcasing unified pipeline transforming raw alerts into actionable intelligence. In summary, this capstone demonstrates how Google ADK, MCP, deterministic AML controls, enterprise security guardrails, and Gemini can be combined to build a secure, explainable financial crime investigation workflow. The project reflects the concepts taught throughout the Google ADK course while addressing a real enterprise problem. Thank you for your time.